In this session, we're going to discuss together the rules of differentiation. What's the meaning of the first derivative? The first derivative is the slope of the tangent of the function. So if we have a function like f of x equals x to the power of 2, when graphing this function, we are going to get a parabola. And if I want to find the slope of the tangent at any point, the slope of the tangent of this function at any point is going to be 2x. What happened? Just multiply the power here by the coefficient of x. The coefficient of x is 1. Multiply the power here by the coefficient of x. So 2 times 1 is 2. And subtract 1 from the power. It's going to be 1. So 2 times 1 is 2. X to the power of 1, which is 2x. What if we have a function like this one, and I want to find the derivative of this function, the slope of the tangent at any point? By using the rate of change rules, we can reach to a conclusion, which is dy over dx equals, multiply the power here by the coefficient of x, which is 1, so it's 4. 4 times 1 is 4, then subtract 1 from the power is going to be 3. So dy over dx equals 4x to the power of 3. That's it. Let's go to the next one. I have a function f of x, 3x squared minus 4x plus 5, and I want to find f prime x, or dy over dx, or the slope of the tangent to the curve at any point. So 3x to the power of 2. How can we find the first derivative of this function? Multiply the power here by the coefficient. That is the conclusion we have reached from the previous lessons. 2 times 3 is 6, and subtract 1 from the power is going to be 6x to the power of 1. Minus. What is the derivative of negative 4x? You know, negative 4x, the power here is 1. So multiply 1 by negative 4 is going to be negative 4. Then subtract 1 from the power is going to be x to the power of 0. So that negative 4x to the power of 0 is equal to negative 4, and x to the power of 0 is 1. Negative 4 times 1 is negative 4. So the derivative, the first derivative of negative 4x is going to be negative 4. Then what is the derivative of 5? The derivative of 5 is 0. And what is the mathematical meaning of the derivative of 5? You know, if we are talking about 5 only, f of x equals 5. You know, 5 here is represented by a straight line parallel to x-axis, and the slope of this line at any point is 0. So the first derivative of 5 equals 0. So dy over dx is going to be equal 6x minus 4. The next. Here in this function, I have x multiplied by 3x to the power of 2 minus square root of x. We can write it as x to the power of half. Then do expanding. Multiply x by all terms inside the brackets. So x multiplied by 3x squared is going to 3x to the power of 3. Minus x multiplied by x to the power of half is going to be x to the power of 3 over 2. What is the first derivative in this case? Just apply the same rules, the power rule we have learned. So 3, multiply the power by the coefficient. 3 times 3 is going to be 9. And here, subtract 1 from the power is going to be 9x to the power of 2 minus. Here I have x to the power of 3 over 2 multiplied by the coefficient of x, which is going to 3 over 2x. Then subtract 1 from the power. 3 over 2 minus 1 is going to be half. We can tidy it up and write it as 9x to the power of 2 minus 3 over 2. And x to the power of half, which is root x. I want to find dy d over dx, the derivative with respect to x, for 1 over x to the power of 3. You know, I wanna get the first derivative with respect to x. We can write this function as x to the power of -3 because we are differentiating with respect to x. So that is going to be -3, multiply the power here by the coefficient of x, -3, and subtract 1 from the power. -3 minus 1 is going to be -4. And find the derivative of x with respect to x is going to be dx over dx, and dx over dx equals 1. So that is going to be -3x to the power of -4. And we can tidy it up and write it as -3 over x to the power of 4. Let's go to the next one. Here I have two functions, and I find it's hard mission to expand. But if we have two functions like u and v, so what is the y dash for the first derivative of the two functions? Write the first function as it u multiplied by the derivative of the second, plus write the second function v multiplied by the derivative of the first. So it's u v prime plus v u prime. And here I have two functions. Let's consider x to the power of 2 plus 3 as u here. And the second function is x cubed minus 3x plus 1, which is v. So what is y prime in this case? Write u as it multiplied by the derivative of the second function. What is the derivative of x to the power of 3 is going to be 3x to the power of 2, and minus 3x, the derivative of minus 3x is going to be minus 3, plus, write the second function as it. The second function is given as x to the power of 3 minus 3x plus 1, multiplied by the derivative of the first function. And the derivative of the first function is going to be 2x, because it's x squared. So the derivative of x squared is going to be 2x, and the derivative of 3 is 0. Then tied it up by multiplying, if you want to simplify it, or you can leave it, and that is the first derivative of this function. Here we have two functions. They are x squared plus 2x plus 5 divided by x squared minus 5x plus 1. And to find the derivative of this function here, it's u, this is the first function, divided by v, the second function. In this case, y prime equals v multiplied by u prime, the derivative of the numerator, minus u multiplied by v prime. V prime is the derivative of the denominator over the denominator squared, it's v squared. Once again, we have up and down. What is the y prime in this case? Y prime equals down, the denominator, multiplied by up prime, up prime. So down derivative up minus up derivative down over down squared. Okay, so here let's apply the rule. So write the denominator as it, as x squared minus 5x plus 1. That is the denominator multiplied by the derivative of the numerator. What is the derivative of the numerator in this case? Is going to be 2x. The derivative of x squared is 2x, and the derivative of 2x is 2. Minus up, right here, the denominator, the numerator, sorry, x squared plus 2x plus 5, multiplied by the derivative of the denominator. And what is the derivative of the denominator? It's x squared minus 5x plus 1. Its derivative is going to be 2x minus 5. over the denominator squared. So write it as x squared minus 5x plus 1, all raised to the power of 2. That is the first derivative of this function. What if we have two functions here, and y is equal to z plus 1 over z, and xz equals 1? You know, in this case, we can find, because it's a relation between y and z, so we can find dy over dz. And what is dy over dz here in this case? You know, y is equal to z plus 1 over z, which is z raised to the power of negative 1. So what is dy over dz? The derivative of z is 1, and the derivative of z raised to the power of negative 1 is negative z, and subtract 1 from the power, it's negative 2. We can tidy it up and write it as 1 minus 1 over z squared. That is dy over dz. And here I have a relation between x and z. So I want to get dz over dx. So we can write xz equals 1. We can divide by x both sides. So z equals 1 over x. So z equals x raised to the power of negative 1. I moved it up and changed the sign of the power. Then dz over dx equals, here it's negative 1, the power is negative 1, so it's negative x, and subtract 1 from the power, it's negative 2. We can tidy it up and write it as negative 1 over x squared. I want to get dy over dx. That is called in math the chain rule. So dy over dx is going to be equal dy over dz multiplied by dz over dx. That is the chain rule. And dy over dz in this case, it's 1 minus 1 over z squared. Multiplied by dz over dx, it's negative 1 over x squared. Because it's a relation between dy over dx, so we can substitute z and write instead of z, write 1 over x. We can write instead of z 1 over x. Okay? So here we are going to substitute z here. Instead of z, we are going to write it the same. It's dy over dx. It's 1 minus 1 over z squared. And z is equal to x to the power of negative 1 raised to the power of 2. So it's 1 over x to the power of negative 2. Because z equals x to the power of negative 1. I want to get z squared. So z squared equals raised to the power of 2. So that is going to be equal z x to the power of negative 2. All multiplied by negative 1 over x squared. That's it. That is the dy over dx. Here in this function, I want to get dy over dx. And I find it's hard mission to expand x squared minus 3 or raised to the power of x. But we can deal with it as y equals t to the power of 6. So in this case, what is dy over dt? dy over dt in this case is going to be 6t to the power of 5. And then find the derivative of t with respect to y. Here, dy over dt. So here I have two functions. Okay. Y equals x squared minus 3 or raised to the power of 6. So we can find dy over dx. We are going to differentiate the brackets as a whole chunk, which is 6 multiplied by x squared minus 3 here, x squared minus 3, all raised to the power of 5. What is the next step? Find the derivative of this function with respect to x, multiplied by the derivative of what inside the bracket. So what is the derivative of what inside the bracket? It's 2x here. So once again, what I did, y equals x squared minus 3. Here, that is the function, or raised to the power of 6. So dy over dx is going to be, find the derivative of the bracket multiplied by the derivative of what inside the bracket. So it's going to be 6 and x squared minus 3 all raised to the power of 5 multiplied by what is the derivative of what inside the brackets? It's 2x. Okay, so here dy over dx is going to be 6x squared minus 3 all raised to the power of 5 multiplied by 2x. We can tidy it up and multiply 2x by 6. 2x by 6 is going to be 12x. And here it's x squared minus 3 all raised to the power of 5. Okay. Let's go to the next. Here is the last example in our session. I want to find d over dx of this function. So we are differentiating with respect to x. So what is the derivative of y raised to the power of 5? It's 5y raised to the power of 4. Then find the derivative of y with respect to x. It's dy over dx. So what is the differentiation of d over dx, y raised to the power of 5? It's 5y to the power of 4 multiplied by dy over dx. Here in this function, we have y raised to the power of 3, and I want to get dy over dx. So we can raise the two sides to the power of 1/3, 1 over 3, just to get rid of this power and write it as y. So y is going to be equal to 3x squared minus 4 all raised to the power of 1 over 3. Then find the derivative of this function dy over dx is going to be equal to, multiply this to 1 over 3, the derivative of the bracket as a whole chunk, 3x squared minus 4. Then subtract 1 from the power. It's going to be negative 2 over 3. Multiplied by the derivative of what inside, what is written inside the brackets. So 3x squared minus 4, the derivative is going to be 6x. Okay. We can tidy it up, and don't forget the derivative of negative 4 is 0. We can tidy it up and simplify by 3(1) and by 3(2). So that is going to be equal to x. And here we can move it down and write it as 3x squared minus 4 all raised to the power of 2 over 3. That is going to be equal to 2x over, here raised to the power of 2 over 3. We can write it as the cubic root, okay, of 3x squared minus 4 all raised to the power of 2. That's it. I hope you enjoyed this session. See you in the coming episodes. Goodbye.